Okay, so now we're going to introduce the foundation for the mathematics in your entire chemistry career. So for those of you that are going on and going to be taking 2 semesters of Gen Chem, Chem 111 and Chem 112, this is the same thing you're going to do over and over and over. So if you get this now, you will be rock solid as you move forward, and that part will not be something you have to learn and struggle with again. That's the beauty of starting with Chem 101 here at Delta. We introduced the concept of unit equations and unit factors and equivalency. Now, this has a lot of names, and I know some of you have had high school chemistry, so you might remember some things from that, where they talked about either the conversion factor method or dimensional analysis or factor label method. And I know at Heritage High School, where my kids went, they called it the action line. Does any of that sound familiar to some of you? Okay, good. If you don't remember any of that, then it means you won't get all mixed up with that and you can do it as a fresh start. So when we think about relationships in chemistry, we're looking at converting information in one form with one set of units, like a mass unit or a volume unit, into something else, some other unit. So if we pay attention to the units, then we can just grab our calculators later and make the numbers all come out right. But the units are the key. So when we look at this relationship, we're going to start with something you know. 1 dime. How much is a dime worth in pennies? 10, right? 1 dime is equal to 10 pennies. So when you're standing in the store, you can start counting those pennies that are wearing a hole in your pocket. And so we say, okay, there is an equivalency, and I'm going to call this D and P. 1D is equal to 10P. So we can use this relationship to make 2 factors. So we know that 1 dime is equal to 10 pennies. Now, the rules of mathematics and algebra say that whenever you feel like it, you can divide an equation by whatever you want as long as you divide both sides by the same thing. So I am going to randomly, just because I feel like it, divide both sides by 10 pennies. So 1 dime divided by 10 pennies, or 10 pennies divided by 10 pennies. So now when we look at this, we have 1 dime divided by 10 pennies is equal to, well, what's 10 divided by 10? 1. What's pennies divided by pennies? Well, I don't know. They didn't teach us how to divide pennies in algebra. What's anything divided by itself? 1, right? 10 divided by 10 was 1, so penny divided by penny is 1, right? So this is equal to 1 times 1. It's equal to 1. So what this means is that the fraction 1 dime divided by 10 pennies is equal to 1. So if something is equal to 1, I can multiply anything I want by 1, and it doesn't change that anything, does it? So now I can use this factor, and if I multiply by 1 dime over 10 pennies, I can get the units, dimes or pennies, to cancel out, but I don't really change the value of the number. I just change the units, so it'll look like a different number because it has different units. So an example of this would be if I have 25 pennies, and I want to know how many dimes are in 25 pennies. So I multiply. I know that 1 dime is 10 pennies times 25 pennies. So now I focus on the units here. I have pennies on the bottom and pennies on the top. So that means I'm dividing pennies by pennies. And we said pennies divided by pennies is equal to 1. So it cancels out. So now I grab my calculator. 1 times 25 divided by 10, and I get 2.5 dimes. So 25 pennies is equal to 2.5 dimes. Everybody agree from your knowledge of our money system? Okay, now you'll notice that we've been talking about sig figs, and I only had one sig fig in these numbers, and I wrote down 2 because that's what the calculator says. Now, if you rounded, it would be only 2 dimes, but we know that those extra 5 pennies makes it more than 2 dimes, right? And we also introduced this idea of exact numbers. Our money system says 10 cents is a dime. Is 9 cents maybe 1 dime and 12 cents is another dime? No, it's always 10 to 1. So we think of those as exact numbers or exact equivalents. So if you look down here, sometimes our conversions are exact equivalents or exact numbers, and they have no uncertainty. I know exactly how many pennies are in a dime. And so these are definitions. There are 10 pennies in a dime. There are 100 centimeters in a meter. There's 12 inches in a foot. Those are definitions, so they are exact numbers. And because they are exact numbers or counting numbers are exact also. Then these have no uncertainty, so they have an infinite number of significant digits, or infinite sig figs. So it's okay for me to report 2.5 dimes because I had 2 sig figs in this number. So we're going to talk about this as we go through this conversion factor process. Now, I came up with this 1 dime over 10 pennies and showed you how it works. The interesting thing is, for every equivalency, you can actually get two different factors. So I have 1 dime is equal to 10 pennies. And now I'm going to randomly divide both sides by 1 dime. So 1 dime divided by 1 dime is 1 is equal to 10 pennies over 1 dime. So I could also multiply the whole thing or anything I wanted by this factor, and I would not change the value. So we get 2 factors, and we just turn it upside down to get one or the other, and they are both mathematically equivalent to multiplying by 1. So that is the foundation for the way we're going to do math. Now, when we are converting numbers within a system, then the numbers are exact numbers. If we are converting between measurement systems, they are not exact numbers. So what does this mean? In the English system, 1 foot is 12 inches. It's not maybe 13 inches. It's not maybe 11 inches. It's exactly 12 inches. 1 pound is 6 ounces. Those are exact numbers, so there's no uncertainty, so they have as many significant digits as we want. In the metric system, 1 meter is exactly 100 centimeters, not maybe 98, not 103. 1 meter is 1,000 millimeters. So even though the way I wrote those numbers, how many sig figs are in this 1,000? The way I wrote it. 1. But there are as many as I need because it is an exact conversion. So we're going to use this information for the unit analysis method, which is also called the factor label method, dimensional analysis, the action line, all sorts of things. So here's how it works. You read the problem. Yes? What did I write? Yeah, 16. I used my invisible ink there. I'm having a hard time. I've been running short on sleep this week and talking and looking and trying to smile. It's the smiling that gets me, trying to look at all of you and be pleasant. Would you be okay if I just looked grouchy and don't try to smile at you all the time? Because this smile is killing me. That's how you prefer, is just being grouchy? Yeah, that works for me too. This smiling all day stuff. And not crossing my arms. It's killing me to remember to stand with an open posture and smile and be pleasant, and to remember to be caring and kind in my demeanor. And I'm telling you, it just pretty much uses me up, just that part. And then to think about chemistry and talk at the same time, I don't know. I think it's time to stop this recording.